Hi everyone, this is coming to you from Education for All. As we are still working on the definition of epsilon delta of a limit, this is the proper definition of a limit and the most rigorous one. We are given a function here, f of x equals x plus 3. And as the limit approaches 2, when you have this function f of x equals x plus 3, if x is approaching to 2, our definition here, x is approaching to a. Now we are saying that f is approaching to 2. So what would be the value of this function? So it's going to be 2 plus 3 is going to be 5. So the limit f of x of the function x plus 3 as x approaches 2 is 5. And we define this definition of limit. This is for all epsilon. This is a symbol in mathematics. It reads for all epsilon greater than 0, there exists a delta greater than 0 such that the absolute value of x minus a is greater than 0 and less than delta. And that implies the function, the absolute value of the function f of x minus the limit is less than epsilon. This is the definition. How in mathematics they will just write it like this. They understand. So that's the definition of a limit. So here you can see that for all epsilon, so it means your input is epsilon. For all epsilon greater than 0, it means you are given epsilon. If you're interpreting it, because you can see epsilon, delta, absolute value of the function. These are distances. This is absolute value on the x-axis and the absolute value on the y-axis. They are distances. So it means from this statement that you are given epsilon, and the epsilon is given to you, you now want to find delta. That's what this statement is talking about. If you watch the previous video before this one, what I explained about that, the distance you move to target your 7 centimeter hole, then you will know that if you are given that centimeter as your target, so how much you're going to move. So that is what you need to find, the delta, how much you're going to move towards your target. That is the delta. So the epsilon is given to you. Or some way around, you can find it. It's easy to find epsilon. Because even if they give you a function, a sequence, you can always find epsilon. So you use epsilon to work out what the delta is. So now let's look at this graph. Let us understand when we are talking about this function, the limit, the epsilon, the delta. Let's understand it from here. We got this function, f of x equals x plus 3. It's like you having a function y equals x plus 3. So when you plot this graph, this is a straight line graph, you get this graph. It will intersect the y-axis at 3 and intersect the x-axis at minus 3. So for this function, this is the graph. So we are going to investigate this function. And we say that as x approaches to 2, f of x is 5. Now, let's say it's approaching to 2. So by how much? By how much? Let's say f of x is approaching to 2 by 5. Sorry, by 0.5. Am I recording? Yeah. By 0.5, just an example. Let's say that. So you will have You want f of x to be within 0.5. So you will have, I'm using the red ink, f of x, mind you, is your function of the graph. So you'll have f of x minus 5 is less than 0.5. This is what you want. You want f of x to be within 0.5. As I told you, you are always given epsilon. That is the epsilon they have given you here. It's the delta you want to calculate. This delta, the horizontal displacement or the horizontal gap. The whole idea is whatever epsilon you are given, they want to make sure that the y value, the limit 5, is always within that range. We'll use this graph to explain that. So if you have this kind of function, this is telling you now that this function f of x, this is an inequality sign. Yeah. So it's telling you is this function here, the limit, which is 5. So now if you take, this is giving you is either 5.5 or 4.5. I hope you know this. I hope you understand it. Yeah. If you have this, this is going to be y. This is your function still. So it's telling you that the y value is between 4.5 and 5.5 when you put this value here 0.5. If it has been 1, so it's going to be 6. It's going to be between 6 and 4. You take away on the left-hand side and you add on the right-hand side because of this inequality sign. This is how we deal with the inequality signs. Right. So now let's see. If you have this band, 4.5 and 5.5. So 4.5, this is 4.5. So it's going to be here. So let's extend it here. And 5.5 is going to be here. 5.5. Right? And this is your epsilon. This graph is not, the gradations here are not, have not been spaced correctly. Let me adjust that. 1, 2, 3, 4. This has to be 6. So this is 6. Five. So I have 1, 2, 3, 1, 2, 3, 4, 5, 6. Yeah, the graph is not drawn to scale. I just want to explain the idea, right? So now we are given the epsilon, which is always given to you, one way or the other. It is given to you. Whether it comes as a function, you will work it out. We'll be able to find it. Yeah. So when you are given this, now you are saying that I want the output to be 0.5 within my function, f of x. So in that case, how close will my delta be to 2? That is what we are trying to find out here. The function, the limit is 5. You want to know how close Your delta is here. The previous example I gave you, you have a dart, you know, the dart. This is the dart, yeah? You have your red spot here, your target spot, and you want to hit this target within 7 centimeters. When you're throwing your dart, you want to hit that target, that hole, within 7 centimeters. So you are already given 7 centimeters target. That is the epsilon. Now, by how much you're going to move your hand to get that target, that is your delta. By how much? You're coming closer, closer, or you're going further, further away. So that is what we are talking here about, delta and epsilon. Fine. So now you are given your delta, which is 7 centimeters here. But let us don't go with this. This is just an intuitive explanation. Let's follow the proper way. So when you are given this 0.5 centimeters, because of this is an inequality, so it goes both ways, left and right. So taking it from left, you subtract. So from 5, you get 4.5. If you add 0.5 to 5, you get 5.5. This is what we have done here. 4.5, 5.5. So now you now need to, this gap here, you now need to reflect it on the x-axis. On the x-axis. See that? That gap is what you want. This gap. If I will have drawn this graph to scale, you can see that. So this is now our delta. This is our delta. When you move it a small distance like this, you get what this whole idea is saying, that no matter how little or whatever value, no matter how little that value is, you move epsilon, your limit will always be within that gap. Your limit is 5. That 5, this shade will always cover the 5. The 5 will always be there. More or less, the 5 will not be outside here or outside here of these two vertical lines. So this gap we are talking about, you see that? Your limit will always be within that. So even if you move this by 0.1 or 0.001 or 0.0001, it will just compress. But still, that 5 will always be inside. So this is the whole idea of this. It's strange idea, but very, very important idea. So now we have shown graphically what this epsilon delta is. Our next videos will be proving limits of functions, because that is our target, to tell whether a function is continuous or not continuous. We're going to see whether a function converges or diverges. We need this not only for calculus, but also when we move on to analytic number theory. We shall be using these ideas because in analytic number theory, we study the concentration or the distribution of prime numbers. As you know, prime numbers is the building blocks of all numbers. So that is it. This idea, this strange idea, very strange idea of, there are so many ways they state this formula, this this concept, but the rigorous way of saying it is for all epsilon greater than 0, epsilon has to be positive. That is why you see it here. There exists delta greater than 0, such that the absolute value, you don't want negative value because you are measuring distances. So the absolute value between x and a is greater than 0 but less than delta, which implies that the function of x, the absolute value of the function of f of x minus the limit is less than epsilon. This is the rigorous formula of this. So now we have shown you graphically how the meaning of it. Next time we start to solve problems. Thank you for watching. Bye bye.